Hello and welcome to another iGCSE chemistry video with Mr. S. Today we're going to be looking at the third type of bonding, metallic bonding. Now we can define this type of bonding or describe it by saying it is a lattice of cations, positive ions, held together by their electrostatic attraction with delocalized electrons. And we can see exactly that lattice in the diagram below. We see a lattice, which means a ordered arrangement of ions, positive ions, with a charge of +1 in this case, and we see some electrons around those ions. Now, those electrons do not have a fixed position, that's why they're called delocalized. They can move through the structure. What holds the structure together is the electrostatic attraction between the positive charge, which is the nucleus, the protons in the nucleus, their electrostatic attraction with the electrons that flow freely through the structure. Now, this gives rise to the properties that we know of metals. For example, metals have a high melting point because of the strong electrostatic attraction. They conduct heat and electricity. These electrons are free to flow through the structure, so they are responsible for conduction of electricity. And the third property here, malleable, which means that you can change the shape of a metal without breaking it, is due to the fact that these layers of ions can shift. So you can have movement of a layer without breaking the structure. That's because despite the fact that the layers or the ions can move and shift around, they're still attracted to the delocalized electrons. Often that is referred to as a glue. The electrons are gluing the structure together. Okay? Now, often you will be asked about trends in metallic bonding and the strength. Now, metallic bonding increases with greater charge. So, for example, if you compare the melting point of sodium, which has a charge of +1, and magnesium, charge of +2, magnesium will have a higher melting point. That is because, obviously, there's a greater attraction if there's more electrons present. Magnesium loses 2 electrons. Per every ion, there's 2 electrons flowing through the structure. There will be a greater attraction between the nucleus of the ion and those electrons. So there's an increase with greater charge of the ion. There's also an increase in metallic bonding strength with smaller ion size, and that again has to do with the attraction between the nucleus and the electrons, because the smaller the ion, the closer the nucleus is to the electron, so there is a stronger attraction. So for example, sodium, although has a lower boiling point, melting point than magnesium, it will have a higher melting point than, for example, potassium. So melting point down group 1 decreases, whereas the melting point across here from sodium to magnesium increases. One final comment on metallic bonding is that we can have alloys. Alloys are structures where we've got a mixture of a metal with another metal or maybe a non-metal. A very common example of that is steel, where you've got some carbon atoms in a lattice of iron ions. So we've drawn a little smaller atom that could be carbon, for example, and what that does is it makes the metal, now the alloy, less malleable because the carbon atom prevents that shifting of layers that we talked about earlier. That makes the alloy stronger in strength than the original pure metal. Thank you all for listening. I hope this has made it clear.